Now we are going to deal with multidimensional data analysis. So if we take for granted that we have some kind of database system available and also some kind of ETL processing in order to fill our data warehouse, and we have a general understanding of the overall BI view, we can now concentrate on the structure of the data. Yeah, and actually this first of all is some conceptual kind of thing. It's not so much a technical kind of thing. It's on the conceptual level, although of course it could be, and it is also often implemented within data warehouse systems. But as we will see, it could also be directly used within tools like Tableau in order to do visualization. But the conceptual level is the same, or doesn't change. Yeah. So I have already started last week explaining that, but I'm just starting from scratch here in order to have it here, to have a complete presentation here. So the main elements of the multidimensional data model are measures, so quantitative facts like revenue, cost, profit. And all of you have already know a different name for measures, namely KPIs, key performance indicators. Yeah, so KPIs and measures from the multidimensional data model are more or less the same. Yeah. Then we talk about dimensions. That's descriptive information. So to put the facts into context, for example, in context of time, geography, in context to product. Yeah, we would like to know the revenue for a specific product category, for example. And within the dimensions, we might have hierarchies. So the data dimension, for example, has the day, the month, and the year. These are, of course, they are in a hierarchical order. So the first May 2021, that's a specific day. That's within the month May 2021, and that's within the year 2001. Yeah, so we have a clear hierarchical structure here, and the way such multidimensional models can be described are by means of the so-called star schema, and this could be regarded as some kind of conceptual level, but as well as some kind of implementation within the relational databases. So we cannot regard it in these two ways. Yeah, and since it combines these two views in a suitable way, these two kinds levels of description, conceptual and on the implementation level, so it serves very well our purposes to understand things here. Yeah. So the fact table here in the center, this there we find the measures, so one or more measures, measure 1, measure 2, and so on. And the dimension tables contain the descriptive information, and so I will come to that in a moment. And the connection between the two is given by foreign keys. Yeah. So we have the primary key, dim1 key, and then we have dim1 foreign key as a foreign key in the fact table that refers to the corresponding dimension table. Yeah. And here we see a classical example. Yeah, sales facts. And as we see, sales facts are might quite have a lot. dimensions, yeah, not only 1, 2, or 3, but many more, as we see. And so the usual dimensions are timing kind of things. So the date dimension, some other here fact tables might even be related, might even have a specific time dimension where the hour and the minute of the day is given. Yeah, so if our facts should be that granular that we would like to look at points in time. Yeah, for example, for in a mobility scenario, yeah, where we have some scooters or something like that, and we would like to analyze which hour at the day they have been used most or something like that. Yeah, then we would even have not only have a time dimension, but also we would also have a not only have date dimension, but we would also have a time dimension. Yeah, but here for the sales fact, that might not be so relevant. Of course, that's a decision. Yeah, when you build up a data warehouse, if what is relevant or not. So in that model, we just looking at sales fact on the level of a specific day, and not any more detail. Yeah. Of course, the product is relevant, the customer is relevant, the store, yeah, is relevant, but we might also have different sales channels, not only stores, but also internet and so on, yeah. And also the currency is some kind of dimension, since if the sales fact are with respect to an international company, we might distinguish between local currency and standard currency. And if you have that situation, it makes a lot of sense to have the standard currency amount and the local currency amount, both of them in the same table, although one is derived from the other. But then you would need a further table where you have the where you have the conversion rates, yeah, for different currencies, and that would complicate things a lot. Yeah, so it's a good idea within the ETL process to directly do the currency conversion. Yeah, somewhere, of course, you have to use the correct conversion rate for the corresponding day, of course. Yeah, but this could be part of the ETL process to do that. Yeah. So we also, of course, might have promotions with respect to sales fact, and of course the sales department would be very much interested in the effectiveness of the promotions that they have carried out. Yeah, and so a data warehouse should be able to support such kind of things, or might be designed in that way that it's able to support that. Yeah. So you see, sales facts provide a lot of interesting kind of things that you might like to analyze. Yeah. So with respect to hierarchies, of course, we have the usual suspectives. Yeah, for example, categories and subcategories in the product dimension. Within the data dimension, we have, as I've already explained, yeah, the corresponding the day, that's the date itself, yeah, the month, the quarter, and the year. And since many companies have a distinction between the calendar time range and the fiscal time ranges, we might have a calendar year, and we might have a fiscal year, and a fiscal quarter, and a calendar quarter. Yeah, so that would mean that the date dimension has two hierarchies: one, the calendar hierarchy, and the second, the fiscal hierarchy, the fiscal date hierarchy. Yeah. Yeah, so many dimensions might have hierarchies. Yeah, one that I should mention is geography hierarchy. So, for example, the customer has a geography hierarchy, and the store also has a geography hierarchy. Yeah. So, and of course, you might, or something that you might also like to analyze is if you have a certain store from which geography, from which place the customers are visiting your store. Yeah, is it only your own? Is it only within your own, let's say, city or zip code, or are they from other ones? So, for example, if you are deciding or want to decide to create new stores, yeah, such kind of analytics here with respect to the different geography hierarchies might be suitable to support that. Yeah. So you see, a whole lot of things could be done here with sales transaction facts, but also in order to provide some kind of fact table here, you must have a good database. All this data must be available. Yeah, you must be able to have sales facts related with promotion events. Yeah, and that by no means is obvious to easy and obvious how that could be done, because the different information could be in different databases and so on. Yeah. Okay, so if we look at the sales facts here, one thing that is important to understand is the granularity of the facts. So on what aggregation level we have fact records, and the general rule of thumb is, please use the most detailed granularity level that you can deal with. The more granular your data is, the more granular your analytics could be. As soon as you have a high levels of aggregations for your fact data, some low level insight might not be able to be derived from the data. Yeah. So, what do you think? What is the granularity level here of sales fact? Have you any ideas how that could be described and explained? Okay, then let me ask another question. The sales facts here, is the lowest granularity level the month level? What do you think?
No, maybe the day level, and also we can go with time if possible. So
Yeah. So in this fact table, data is represented on the daily level, but not on an hourly level. Yeah, we cannot do analytics on an hourly level. That would not be possible here to do, but on a daily level. Yeah, but of course, for many analytics, that's perfect. So let me ask a further question: is the granularity level here the singular order or a bunch of orders, or what do you think? What is the granularity level here of the sales fact? Or is it suborder granularity level even? It is suborder level, because if you regard one order that might contain many products, many order items, of course, yeah, but each sales fact here is related to the product dimension, and it's related to one specific product. So for example, if you have an order where you have bought 3 products on it, milk, butter, and bread, for example, then you would get 3 sales fact records here in it. Yeah. Otherwise, if it were here on the order level, you will not be able to analyze things on the product dimension. Yeah. So your ETL process has to extract from each order the line items in order to put them into the sales fact table. Yeah. So this is the most granular kind of thing. Yeah. Per day, per product. Yeah. But and per store, of course, also. Yeah, but if within the same store on the same day, the same product have been bought by the same customer twice, yeah, that would be condensed into one sales fact here, because we have it on the customer dimension, on the store dimension, yeah, on the product dimension, and on the date dimension, yeah. So if the same customer is visiting, let's assume he has bought butter in the morning, and in the afternoon he noticed, I need further butter, and he again goes into the same store and buys butter again. Then you could not distinguish these two events here, because it is.
But we have a transaction number over here, right? POS transaction number.
Yeah, you are right. Let's see. You are right. You are right. Yeah, I'm wrong. If you wouldn't have the transaction number in it, then it would not be possible to have it. Yeah, but the transaction number is in it here, and therefore it is correct. Yeah. So as we see, it's even more granular, and actually this transaction number here, this is also some kind of dimension, yeah, but it has no specific dimension table on it, yeah, but you're completely right, yeah. So even if a same customer buys it 2 times, we would be able to distinguish that here in the sales fact table. Yeah, thank you very much. Yeah, so you see, it's each singular sales event by itself generates an entry in the fact table. Okay, I hope you got an idea what granularity level means within a data warehouse within a multidimensional data model. Yeah. Are there any further questions here to the sales transaction facts? Okay, then let's talk about a second kind of fact, so-called snapshot facts. They are a little bit different from the transaction facts. So transaction facts are about each singular transaction, so about each singular event. And snapshots facts are more about state. Let's look at the example. Again, we have a fact table in the center here, and that has a measure that's called quantity on stock. Then we have the data dimension again, the product dimension again, and an additional dimension here, the warehouse dimension. Yeah, and the granularity level here of that snapshot fact table, that's not, let's say, the single the single arrivement of a of a product within a data warehouse, yeah, but it's more about the overall state on a specific day. So actually, quantity of stock is one has to decide if I have it on the granularity level of a specific day, what quantity on stock with respect to that specific day means. Do you have any idea what it could mean? Because the quantity on stock could change within one date, yeah? So it could be replenished, but you could also take products from the data warehouse. So what do you think you would like to see as quantity on stock in this snapshot fact table?
Maybe it could be the one that is added into the inventory.
So quantity on stock should be the number of items that are added to the warehouse.
It could be in the total change in the stock, I guess.
Yeah. So actually, here we are not talking about change. That would be a transaction kind of fact, but we're talking about state. The idea here is state. So if we would like to talk about change, we wouldn't need a further transaction. We would need a transaction here fact table for the data warehouse, yeah, for the warehouse, not data warehouse, for the actual physical warehouse, yeah. But if we are talking about the state, so we would like to analyze, for example, how good we are able to fulfill order requests, yeah, and so we would like to have a stock level per day. What options do we have to define quantity on stock?
The left stock, like what is the stock left every day?
Yeah,
Like,
so actually it could be the day end quantity on stock. Yeah, what is the quantity on stock at the end of the day? Or it could be what was the quantity on stock of the beginning of a day, yeah. Or it could be the average quantity on stock for that product all over the day, yeah. So here I'm talking about this general state in order to do some kind of analytics with the general availability, yeah. And this has to, of course, has to be distinguished from this from the analytics of the different events of a stock that gets into the data warehouse and stock that gets out of the, not the data warehouse, of the warehouse, yeah. That would require a different fact table, but here we are talking about the general state, and then we have to define it, yeah. So, for example, for banks, yeah, we might have the same kind of thing. We would have the bank account, the value of the bank account at the end of the day or the beginning of the day, yeah. So the things I want to emphasize here is that that's a snapshot in contrast to a transaction fact, and snapshots facts. You are not allowed to add them on the date dimension because that would not make sense. So if you have today a specific quantity on stock and you have tomorrow a specific quantity on stock, it does not make sense to add them because you don't have twice the number of entity of products on stock, yeah. And these are called semi-additive. Yeah, so please keep in mind, we have transaction facts, we have snapshot facts, and they serve different purposes. And we have a third kind of fact, namely so-called process facts. And they are even more complicated. For example, we have many times the data dimensions as a dimension. So the data dimension serves different roles within these process facts. So for example, you could have a date received foreign key and a date inspected foreign key and a date picked foreign key and a date shipped foreign key. Yeah. So you have 4 foreign keys from the process fact table to the data dimension. Yeah. So that's typical for process fact that the data dimension is used in different roles. Yeah, of course, we also have the product dimension and the warehouse dimension. And having these states here, you can imagine that you are now able to analyze processes. So how long does it in general take from receiving things at the entry of the warehouse until it gets inspected? Yeah, and how long takes it, for example, after a product has been picked until it is shipped, and so on. And if you combine it with order facts, you might also analyze how long does it take from order entry to shipment. Yeah, but then you need a further fact table for orders, and there you would need, of course, also you would need you might also need a real-time dimension with hours and so on. Yeah, so if you would like to carry out analytics on an hourly level, yeah, then you would not only have the data dimension here, but you would also have the. Okay, now we have got a first impression about of what the multidimensional data model is. So we have the fact tables and we have the dimension tables. That means we have these measurements that are part of the fact tables, and we have the description that are part of the dimension tables. Yeah, we have seen three kinds of facts that usually we might come across, namely transaction facts, and actually transaction facts are the most prevalent ones, I would say. Then snapshot facts, and the least used kind of facts are process facts. Yeah. So up to now we have looked at a singular fact table. So the star schema just talks about one singular fact table. But if we look at a real data warehouse, we usually have many fact tables that also share dimension tables. Yeah, and such kind of schema here, where you see we have here three fact tables here in the center, and around that the dimension tables. That's also called a galaxy schema. Yeah, the galaxy as a composition of stars. And since different fact tables refer to the same dimension, for example, all here fact tables here refer to the product dimension and to the date dimension and so on. The meaning of the dimension must be the same for each fact table. Yeah, and that's called a conformed dimension. So that might sound obvious that should be the case. Yeah, so that if I have different fact tables here, the product dimension has the same meaning for all of them. But in practice, that's not always the case. So, for example, if the product departments build its star schema and the sales department builds its star schema, the product dimension for both of them might be quite different. Yeah, so they might have different descriptive elements and so on. Yeah, that definitely will be the case. Yeah, because the product people, the production people look from a different viewpoint onto products than the salespeople. Yeah, and therefore that usually takes some work in order to provide conformed dimension, and often that's hard work. Yeah, you might remember last week when we have talked about business performance management, about this information architecture, that there should be an agreement of common terms. That's exactly what the discussion about on conformed dimension is about. Yeah. So this, in order for this to make sense, we must have conformed dimensions, yeah, and then now that would here be a more comprehensive data warehouse, yeah, where we have several fact tables and a bunch of dimension tables. So let's now take as a special example procurement, since you are in the procurement branch of the MBA department of the MBA program. Yeah. So if we look at procurement transaction facts, we might encounter the following. First of all, of course, we will have our product dimension. Yeah, we will have our data dimension. They are quite they are available, of course, in many scenarios. Yeah. But for example, in the procurement transaction, we might have an employee dimension that was not part of the, for example, transaction fact scenario, and we might have contracts. Yeah. So we might have a so-called contract terms dimension. Yeah. We might have discounts. We might have a discount dimension, a vendor dimension. Yeah. So a lot of things, a lot of further dimension might be there. Yeah. So let's see what kind of facts might be interesting. For example, we might have a purchase requisition fact table. So this table would have the following content. So we would have here we would have all the foreign keys, and actually let's see, the data dimension should also be connected to the purchase requisition fact. Okay, let's see. So as it is given here in the graphics, we see the purchase requisition fact is related to an employee, that's the requester. Yeah. And it is referring, for example, to term contracts, to discount, to a product, and to a vendor. Yeah. So this fact simply states which employee is requesting what product, under which terms, contract terms, and under which discount. Yeah. So it has a purchase requisition number, and it has a quantity, and has a requisition dollar amount, for example. Yeah. So if we look, for example, at a purchase order fact, yeah, we would have, for the purchase order, we would have the requisition date, we would have the requested date, then we would have the order date. Yeah. So for example, the requested date means that you have a request to the vendor. Yeah. And if that is there, then when the actual order has taken place. Yeah. So we might have order purchase facts. Yeah. Then we might shipping notice facts, warehouse receipt facts, vendor payment facts. So you can assume if all these kinds of facts are available, yeah, then you're in a position to thoroughly do analytics on your procurement processes. Yeah, you can, for example, figure out how long does it take from request to order, or from requisition to order, or from request to receipt. All kind of KPIs could be calculated from that. Yeah. So you could also analyze it according to usage of contracts. Yeah. About saving that you have had according to discounts that have been got, and so on. Yeah. So also here you might notice that building such kind of multidimensional model, yeah, would require quite some work, yeah, in order to have this analytics. And this is always the case, yeah. if you want to do solid analytics, you must provide solid base structures on which you can rely on. Yeah. Okay, so that would be some kind in the procurement area. So let's see what else we have. Yeah, to sum up these kinds of facts that we have had, transaction, snapshot, and process facts. Yeah, we could state the following: the grain of the facts is within the transaction domain is 1 row per event. In the snapshot, it would be 1 row per period, for example, for a whole day. So either a quantity on stock at the beginning, or the average over the day, or at the end or so, but it would be 1 row for 1 day, for each day. And in the process, it would be 1 row per process. Yeah. So, of course, your fact tables have to be loaded from the operational data, and the fact table loads in the transaction area would simply be inserts. In the snapshot would also be inserts, but the process table might also get updated, because for further states within the product in the process, you have to update the corresponding date column. So, is fact row update common, or does it take place? For transaction, you usually don't update things. One exception might be if you have errors, but even then you might handle it by in another way, yeah, by compensating transactions. I'm not going to in the detail of that now. But usually you don't do updates, you just add, yeah, for facts also, but for process you do update. And the data dimension that plays a specific role here, usually in the transaction fact, is the transaction date, whereas in the snapshot table, it's, for example, the end of period date. You might also have snapshot here facts for whole weeks or for a whole month, yeah, not only per days. And in the process, we have multiple dates. Yeah. All this kind of stuff we have discussed here could be applied to many different domains. So for example, we could talk about healthcare, telecommunications, yeah, banking, insurance, and so on. And all these domains have their own kinds of facts. Yeah. For example, in telecommunications, we might have calls. Yeah. In banking, we might have access to automatic teller machines and so on. Yeah. There might a lot of different kind of in this different kind of areas, this multidimensional setting might be applied. Because the setting is quite general, yeah? We have these measures and we have these dimensions, and this is a quite widely applicable concept. Yeah, all these domains could be structured in that way. Yeah.